afternoon, everyone. Now, just both of you, Mr. Sean and Miss Mary.
Hi.
My name is Wayne. Today is my pleasure to be here to share with you guys our insulation experiment. And you know what? Our topic is pretty long topic, pretty short. Insulation can be a tool in fighting global warming. And now I want to show you guys some background research. The greatest issue on Earth. 3 months ago, there is an extreme temperature event in Antarctica. You know what? It was never happened. That was break the record of 33 degrees Celsius. Can you imagine that happening in the world's coldest place? By actually happened. I also want to show you guys another thing. The sea level rise. You guys can see both of these graphs are going up in general. They might going up, down, however, it's just going up by the way. In the past 30 years, the sea level already rise 100.8 millimeters. Just like that, little bit. You guys might say, it doesn't matter. Just a little bit. However, it's the entire Earth sea level, not the local sea level. Can you imagine how much water you put inside the sea? Of course, what does the water come from? The ice. Ice melt for a huge amount. Look at this graph. Every year is like up, down. However, you can see it's just all the way going down. Especially what happened in 2012, it was also never happened in our North Pole. Look at this. The Arctic sea ice was only this amount if you compare to the highest point in 1980. It was much different. Can you imagine how much ice was already melted to the sea? Why does the ice lost? Of course, temperature rise. Why? Humans activity provide a lot of carbon dioxide. Look at this. This is the graph from 2005 to 2022. The carbon dioxide level in atmosphere is going up. Also, did you guys realize when the carbon dioxide level going up is also same thing for the global temperature? What I mean by that is that once the carbon dioxide going up, the global temperature also is going up. Why? They have direct relationship. Carbon dioxide and many different types of greenhouse gases can catch the heat in the atmosphere, which will warming the temperature. Can you guys think about where they come from? Of course, in order to use the energy, we got to burn fossil fuel, oil, and coal. They provide electricity here and for the computer. However, when they provide electricity, they also need to provide carbon dioxide. That is why. And you know what? In the regular building, we spend almost 50% of the energy in order to cooling or heating our building. That's a huge amount. This which comes to next is my wonderful experiment about insulation. That is why I want to show you guys next, ladies and gentlemen. Now we have 3 different groups right here. What I'm showing here also have this just to let you guys see in person. These 3 different groups, which is null insulation, partial insulation, and full insulation. And what we are going to do is that to use the cold cup and the hot cup. Why is it called cold cup? Because we're going to put the cold water inside the cup. That is cold water. That is why we call this is cold cup. And the hot cup, we are going to put boiling water, which is from here to this cup, and then we're going to connect each other by aluminum bar, which is representing our no insulation group. What I want to show you guys is that insulation can help us. Why? If I use this aluminum bar by using material to cover, then when the heat transfer by the hot cup will not easily be lost. Also, if I have this cover to cover each of these, then what could happen is that more heat will lose to the atmosphere. And what my hypothesis is that if we put more insulation material to the cups, then we can transfer more heat to the cold cup. Why? Because the more material we use, the less heat will escape to the environment. The material I already showed you guys, the cups, cover, aluminum bar, also the insulated materials. However, you need something to measure. I also bring something to show you guys, the thermometer. This thermometer is pretty special because it can tell you the room temperature right here and the final temperature, which is measured by this. Also, the boiling water, which is super hot, we cannot use regular thermometer. Instead, we're going to use this special thermometer for our hot cup. Also, we got to use our scale to measure the mass of the water, just to get some clear idea of each other. Every experiment must have some constant variables. First of all, the time is all the same, 30 minutes. Room temperature at that period of time was 25.8 degrees Celsius. And the amount of water in the cold cups is 162 grams for 3 different groups cold cups. Also, same thing for hot cups water in 3 different groups also is 172 grams. Here is the next thing. It's pretty important to let you guys know when you put the aluminum bar to the cup, you must make sure they have the same distance from each other. You cannot put like this. It's too close to the wall. Why? Because if they're too close to each other, when the heat transfers from the hot cup to the cold cup, it can only warm in the much water right here. It cannot warm in the water equally. It's the same thing. When you put the thermometer, we need to make sure everything is right equal, which means that the thermometer right here, it must have the equal distance in order to make sure we can get a correct number. We have some independent and dependent variable. For our independent variable, which is the level of insulation in 3 different groups. And what we are going to measure is our dependent variable, the delta T. What is delta T? The changing of the temperature in Celsius. And we're also going to measure the Q, which is the heat gain of cold cups water. Also, we are going to measure the Q of the heat it was lost from the hot cups water. Here is our control and experimental group. For our control group, of course, there's no insulation for this group. Why? Because we want to make sure to prevent our hypothesis is suppose our idea. So for our experimental group, we use a lot of insulated material. That's why it covered like that. Here is our analysis for the changing temperature. You guys can see the no insulation, which is the blue bar. Also the full insulation, which is the red bar. Also, you guys can see right here, they have the same star temperature, 15.8. Finally, the temperature of two different groups are different. 8.7 for no insulation group.
That's a question.
Yes,
They're almost the same though, no?
I know. However,
Okay.
I know, but they still have some little bit different.
Okay.
You can see the full insulation group that is 9.7 is a little bit above no insulation group. However, not just like that, I also want to show you guys another thing that was much better than the heat that was gained by the cold cup, which is our analysis tool. The cooling down of the hot cup's water. You know what? If the material has more grade insulated, which means that the more heat will stay inside. So for this case, we are looking at the smallest number. And our full insulation win again. Why? Because the number is 19.7. And you see the number for the no insulation group, which is 27.7. It's a huge amount of difference. Your question?
Wait, are those maybe reversed? Because shouldn't the fully insulated hot cup be hotter than the no insulation hot cup?
No, look at this. This is much hotter. This
But the
is
ones-
the
Yeah, for the yellow row. It's less. Look,
Yeah.
that one compared to the 27.
Alright, I know.
Okay.
Yes, I'll explain to you by the way. Look at this. 19.7 is the changing temperature. You know what?
Oh, I see.
Yes.
Okay.
Alright.
Got it.
Now is the greatest part, the calculation of our CO2, which is water. Just another way to say that. How can we calculate the heat in the cold cup? This is the equation Q. I told you guys the heat. How can you calculate the heat? In order to calculate the heat, you must have the mass of the water. That's why we need to use the scale. And then specific heat. What is specific heat? Specific heat is the special unit in order to warm up one substance by 1 degrees. I mean 1 gram by 1 degrees. And the specific heat of the water, which is 1 calorie per gram. Last but not least, the reason I will show you guys the temperature is because I want to let you know the changing temperature. And now let's calculate. The cold cup is 162 grams times the specific heat, 1.0 calorie per gram times 8.7. And what we got, the number is 1,409 calories. If you look at this, the full insulation group is 1,571, which is a little bit more than the no insulation group. Also, the heat loss of the hot cup in no insulation group, the number is 4,700 grams calories. If you compare to a hot cup, it's only 3,300 calories. It's almost 40% less than the no insulation group. A lot of people forgot a special thing. Our aluminum bar is also really special. Why? Because you put the hot cup and the cold cup each other to connect each other, right? It might gain the heat from the hot cup in order to transfer to the cold cup. The aluminum bar is also a type of substance, and they also need to gain heat. That's why you need to calculate. Just make sure they treat fairly. Look at this. For the no insulation group, the aluminum bar only gains 337 calories. If we compare to the full insulation group, which is right here, is covered by the insulated material. You guys can see 573 calories is also much higher than the no insulation group. I know the number looks so confused. That's why I create a pie chart to give you guys some idea. Look at this. The no insulation group. You know, did you guys know what is uncount heat? Right here. Uncount heat, which is the type of heat that was never counted. Why? Because the uncount heat just evaporates to our atmosphere, which means that you will not go to the cold cup, which is right here. Also, will not go to the aluminum bar. They're just running anyway. If you compare to our full insulation, that was a huge amount, 36.7% of uncount heat. And look at this, 63.3%. That's a lot of difference. And you guys also can see the cold cup gain much more than the cold cup in the no insulation group. Aluminum bar, same thing either. However, in this world, there's nothing can be perfect. Our experiment also. You know what? By the beginning, I will show you guys there's three different groups: no insulation, partial insulation, and full insulation. However, the reason I hide my partial insulation group is because the result is not support my hypothesis. Why? Look at this. The no insulation gained 29.6%. If you compare the cold cup in partial insulation, the cold cup in partial insulation, we use this to cover the two cups. However, the cold cup is still lose a little bit, only 27.7. It's not support our hypothesis because you put some cover. You should gain more heat in the cold cup. However, this is just a mistake. Alright, you know why? I think the most reason is because during the winter, it was a few months ago, we must open the window. However, it was much colder than inside the room temperature. Why? Because that period of time was during winter. When the wind comes, it was much cold. And you also can see right here, we have 6 cups. Each cup should have 1 thermometer, right? However, here's missing. You know, guys, I want to tell you guys something for fun. Because we are doing the experiment at the same time as a whole class, so we cannot make sure everybody got the thermometer for each cup, which means we got to share from each other, and the result might be unfair. Everything, our experiment, is connected to the real world. First of all, look at this cup, our IHS insulated bottle. I was pretty love this bottle, you know why? Because when I open this, the water is still hot. You guys can see the air comes out. I just put the water this morning. It's boiling water, and it's already like that. Wow. You know what? If you put this to next morning, it will still be heat. Why? Because the insulation material can help us to prevent the heat to escape. Same thing for the building. If we use the building with insulation material. What could happen is this, according to the primary source, adding new efficient insulation can reduce your home's carbon footprint by 30% and saves you up to 15% on heating and cooling cost. What's that mean? You save money for this. You don't need to cooling all day long. And last but not least, I want to give you a special shout out to our NASA. Why? Because my source are come from NASA. I really appreciate NASA to provide these great resources to us. That is why I can make that wonderful presentation for both of you guys. Without that, I'm not sure what I'm going to do. Thank you so much for both of you to visit my presentation. It was my pleasure. And please ask me questions and give me wonderful feedback. Thank you.
So, based on your understanding of insulation,
Yes.
if we use the same water bottle
Yep.
and we put hot or cold water,
Right.
will it keep the bottle, will it keep the water hot longer or cold longer?
Great question. I did not for this cup either. I mean the bottle. You know what? I was putting a lot of ice with regular temperature. I mean the room temperature's water together. You know what happened after 12 hours? It was still stay cold if you put cold water. So I think that's a great question. I didn't tell you. You are correct. It's the same thing.
Yeah.
Insulation can make sure the cooling, I mean the lower temperature is also not affected by the outside temperature. Great question. Mhm.
I kind of already asked my questions while you were presenting.
Yes,
But
it was great.
yes, trying to think if I have another question.
Did you understand a lot about this topic before Thomas's class?
That was a great question. You know what? Before Thomas' class, I already learned about how insulation material will help us in the war. Even before I come to this country in China, I already learned about. A lot of people learn about that. I'm so happy. You know why? Because if we can learn this earlier to let more people to know it, it will help us to fight global warming. We want to save our energy to make energy efficiency in our house, right?
So, since you already have studied this before, I guess this is my own question. How
Yes.
would you, what would you change about this experiment to make it a better experiment?
Excellent question. I would love to answer this a lot. Next time, if I can do this experiment, what I'm going to do first is to make sure the window is open. Nothing can affect us. And then we got to have all the material. We are not going to run in to take out the people's thermometer to check it. That's like, oh my goodness, what are you doing? Why you are taking us, right? That's not great. In order to make better, I'm going to make my own in the future to get a better result. Thank you.
All right, thank you. Yeah, that's all I got. How about you?
Thank you so much. I hope you guys have a great conversation.
All right. Can you stop the recording?
Yes.
Also? Thanks.
Yes. No problem.